All right, team, here we go. We're going to get started on lesson 11.2.1, and we're going to get nerdy here. This stuff is awesome. I'm a big fan of this t-testing thing and kind of doing random samples to make some prediction in variability is really going to be kind of our big key for this. And specifically, we're going to take a look at a hypothesis test and just kind of what that looks like. As true with the other things, we, of course, are going to be bouncing between Desmos. So we're bouncing the CPM. We're going to bounce into with a TI calculator. And today I'm just going to call it Excel because that's what people know it as, but I'm going to be using Google Sheets. Same idea. And I know that there's some Excel people out there to tell me that that's not the same idea. But for our purposes, it is the same idea. And this is my video, so I could say that. So here we go. Let's see what this looks like here. So it says this, the principal at Algiers Park canceled the winter formal because he does not believe that the students preferred it versus another trip. He told student council that if he could convince him that more than 50% of the school preferred the winter formal, he would reinstate it. So student council decided to select a random sample of students to respond to a survey, but they disagreed on how large a sample should be. Some thought it should be at least 100 students, others thought 25 would be enough. So for simplicity, for convenience, they decided to survey 25 students, and this is our key here. And it turns out that of those 25, that 60% preferred to keep the dance. Unfortunately, the principal said, I'm not convinced. He said, because of natural sample to sample variability, the true proportion of the dance supporters might not be more than 50%. So even though in this survey, 60%, he's saying because this natural sample to sample variability, that it might not even be more than 50%, even though they found 60. So let's see what that looks like here. So to investigate this, we're gonna take a survey that concludes that 60% of students support the dance. That is what our survey results will say. So how we're gonna do that is we're gonna generate numbers between 1 and 100, and anything that is above 60, we will conclude that they do not. So if it's above 60, they do not. If it's below 60, they do want to uh do the winter formal. And then what we're doing with that is we're going to create a sample of 25 random numbers between those two things. Numbers 1 through 60 can represent that they do, and numbers 61 and above, so above 60 will be that. And I should say below 60 and 60 will be that they do that. So here's a couple of different things that you can look at. One, they going back to the TI and the random number generator, we can do that. We can pop that into a list. You can see that the first student would support the dance, the second student would not, because that is 72. It's above that 60 mark, so therefore they do not. 58 does, 23 does. But then here, 95 does not, and 39 does. And then also CPM has this random number generator here that you can use. And let me start to just show you some of this stuff. And we're going to find out. Well, I guess before we get into that, let me get in some of this. So because of the natural sample variability, the portion of students who support the dance in a random sample is probably not 60%. What is the portion of students in your sample that supported the dance? So we are going to generate a sample of 25 random numbers between 1 and 100 and find this out. So here I'm going to jump into let's start off with no, let's start off with the CPM one. So here you would just click these 5 lines here, 5, 10, 15, 20, 25, and you just go through and say, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So in this sample, we have 13 people. So in the CPM sample, we had 13 out of 25 that do not, which of course leaves us with 12. Is that math right? Yes. 12 out of 25 that do. So, which might feel like that's kind of crazy because it's over 50 per percent that do not, and that is kind of right. So then if you want to do that in the Desmos, or excuse me, in the TI calculator, you just jump in here and do your random sample. I'm going to go through this pretty quick because you saw this in some of my other things. So I clicked on the math button. I'm going down to random integer. I'm going to do integers between 1 and 100. And I want to do 25 samples of that to represent those 25 students that they took the sample of. And I'm going to store that into list number one. And I'm going to send that. And then to get in and kind of see that list, I can just kind of click through it here. But again, I get kind of lost there. So I'm just going to go back into stat and edit. And here's my list. So in this list, I had 1, 2, 3, 4, 5, 6, 7, 8, 9. So I had 9 in this sample. So jumping here in my TI sample, I had 9 out of 25 that do not. And then the last way that I'm going to show you here is in Desmos. So here, that same formula, you're just going to say, hey, pick random numbers that are between 1 and 100. And I'm going to put this dot, say, hey, pick random, if I can spell random numbers, and I want 25 samples of that, and you'll get your 25 element list. I already have that, so I'm not going to worry about it. And let's just randomize here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in my Desmos list, I've got 11 out of 25 that do not. So this is really what the principle is talking about here, is that depending on your sampling, you can get a pretty different ratio based off that because it's just a small sample. So let's keep going. And then also, this section is going to be a lot of handwork. It doesn't matter to me if you'd rather use Desmos or TI or CPM. I'm going to end up using a lot of Google Sheets just purely because I think I can just show you that data faster and I can count it faster instead of having to have you watch me count out pieces of data. But long story short is this: you can just do this and just count it out by hand, and it'll be just fine. It'll work the same way. So let's see on the next slide, our next question here, which is going to be this. So each team member should repeat this simulation with 5 more trials and record the proportion of the supporters. Well, in the last one, I already had 3 of those trials. I had 13, I had 9, I had 11. So I need to do 2 more samples of that. But I'm going to show this to you in Excel here, just so that you guys can kind of see not the 100 sample, the 25 sample. So here's my trial 1, 2, 3, 4, and 5. And I've got my 25 samples here. Here were my number that were 60 and below. Here are my number that were 61 and above. And seeing that, and then here would be my percentages. So 52 and 40 and 48 and 64, and there is all that. So I've got some 5 samples here. So we did that, check. Now, if you were to combine your portions with those of your classmates, what do you suppose the mean of all those samples would be close to? Well, here in theory, when I think about that, so I am just going to think about that before I actually try and do it here. Um, so if I think about what that, just so you know, just thinking, I was wondering if this one asked me for a mean, but it didn't. So yeah, so if you were to combine those with those of your classmates, so if I have, let's say that there's 25 kids in my class, so let's say that there's 24 kids in my class, and plus you makes 25. So if I take 25 samples that are supposed to be at 60%, I'm going to take a guess that it's probably going to get me to right around 60 percent when I go and I take the average of all those averages. Might have I mean, it's possible for it to be off that, but just at that point, I've got 25 samples, and I've got 5 sets of those, and then I'm taking my average of that and averaging it out. Just the data is starting to get kind of heavy there. So I'm assuming that it's going to be around 60. It might be 59, it might be 61, but I'm going to assume that it's going to be around 60 there. Okay. So now next up, for the whole class, what are the upper and lower bounds of your sample to sample variability. Well, here, let's actually look at this here. So here I just went and basically I took these numbers here and this this is person one and they have their five samples. This is person two and they have their five samples. Person three, person four, person five. I didn't end up doing it for the whole class just because that'd be a ton of lines. And then I found and then I went and I found what are the total means of even just these five sets of data for all that. You can see here that I was thinking about doing more, but I decided F5 is enough. And notice that this does hit the mean total of all of these means is hitting that 60 number. So we are seeing that for that part C question right here. If we were to combine all of those here, I'm just turning in a lot of things that should have an average of 60. And so then if I'm just saying what's the average of all those things that should have an average of 60, well, I'm probably in the end, it's going to come out in the wash to that. We saw that over five samples. Definitely, if you put that over 25 samples, you'd probably see even more, or I should say 25 samples of five samples each. That is just a ton of samples. So for the whole class, what are the upper and lower bounds of your sample to sample here? Again, I did not do the whole class. I just did five here. So now here, all that I did to kind of mock this up is I just said, hey, if this is person one, this number here is just going to be their kind of overall. And so I went and I just took these 25 samples and I ordered them from upper to lower bound. And that's because here, when I'm trying to find that upper and lower end, I need to cut off 5% off the top and 5% off of the bottom. And let me show you why here. If I go through and I order this data, well, one of these people found that they had 28%. Well, that's a crazy number. And then here in the top end, so another person found 88%. So it hit um, so just those are crazy numbers and are just really outside of what's even like normal. So this that whole like upper and lower. So since I've got 25 pieces pieces of data, I'm going to take off two and a half of them. So how that works is I'm just going to basically ignore these two, but then I don't want to ignore this one. So I'm going to take the halfway point between these two. So my lower bound is going to be at 44. And just purely the goal is to try to eliminate some of these really low end numbers. And I'm going to do the same thing with my upper. I've got my two kind of crazy pieces of data here, and I'm going to find out what is my median between these two. Well, that'd be 74. So my upper bound is going to be set 74. My lower bound is going to be 44. But my mean I still found was 60. So my mean was 60. My lower was 44 and my upper was 77. So just to write this out here, what are the upper and lower bounds? I've got 44 to 72, I think it was. I already forgot the number. Yes, 72. So that is my upper and lower bounds. So now predict the proportion of all students given the margin of error. So reminder of the margin of error, that's just saying what's my upper bound minus my lower bound. So that'd be 28 here. And then I know that my mean is 60. So all I do is I take that entire boundary and then I split it in half. So 28 divided by 2. And now I know that I've got a 14% change that's happening off this mean. So I'm going to say 60% plus or minus 14%. So this would be my margin for error, would be that plus or minus 14%. So if you think about what that means, what the student council is saying is that 74% of students might like the dance, or going down, I may actually get down to about 56, or excuse me, not 56, 46% of students might not like that because it's plus or minus 14%. So I've got quite a huge range here. I've got a little less than half, or I've got almost three quarter. That's a pretty massive range because this is a pretty big margin for error there. So that I went through that decently fast. Feel free to pause it and go through here. Lots of this is just kind of handwork. Once we get this, just counting out, hey, how many times was I above it? How many times was I below it? And so on and so forth. So now in the previous problem, the claim was made that more than 50% support the dance. Well, when you think about 46% to 70, I already forgot the number again, to 74% like it, you're saying, well, yeah, most of those data points say that. But what that means with this hypothesis test is that it is possible for the actual value to be at 47 or to be at 46 or to be at 50% or to be at 74%. This is not telling you what the actual number is and what eh, but it is saying that it's possible for it to be at 47% for the actual number. That's what the hypothesis test does. So to test the claim to find a sample is taken of the student population and the sample variability is considered. This is called the hypothesis test. So based on your results, does the principal have convincing evidence that more than 50% of the students support the dance? Absolutely not, he does. It could be 46, it could be 47, it could be 48, it could be 49, it could be 50%. All those things would definitely be below 50%. He does not have reason to believe that the student body supports it like the student council is saying. So let's see what's going to happen next. So in 39 here, now they presented the results. The principal's not convinced, and so the student council still determined to persuade him. So they called an emergency meeting, and they agreed, hey, what if we did a larger sample of 100 students? So now, why would they want to survey more students? Just thinking about that, you probably get more accurate. I think there's two C's in that. More accurate information because you've got a larger sample size there. So the larger sample will probably give you less margin for error is the key thing. Margin for error. Because you've got a larger sample, there's probably going to be less of that really high va variability stuff. Like this 28% is just nuts to say that in 25 samples, that is supposed to be an average of 60%, that you hit above 60, like whatever that is, 72% of the time is just crazy. Um, to think about. But if I've got 100 pieces versus 25, well, that gets even harder to hit crazy numbers like that because it's just the rule of averages. It's going to start to do that. We kind of hit this. The margin for error for a sample of 100 students will be larger or smaller. We're thinking it's going to be much tighter just because you've got more. It's just going to be harder to have crazy numbers like that 100 times than it would be 25 times. 25 times it's possible because if you think about some of our counting numbers here, so let's go back up here. So this was, hey, the percent that were above and below. Well, here I've got 15 and 10. Well, if I added two numbers this way or that way, all of a sudden I'm closer to 50% instead of 15 or 10. Or like this one, 20 and 5. Well, if I add a couple numbers this way or that, like this drastically changes that number. But at 100 samples, that's it, like plus or minus one or two is only plus or minus 1 or 2%. This is like plus or minus, two. This is like plus or minus like 5 or 10 or 15 percent. I'm starting to change this percentage way faster when I have a smaller sample size like that. So now it says set up and run the same thing but with 100. So again, I'm going to jump in and I'm going to do this in Excel, and you guys saw this like sneak peek here. But again, it's really easy to do in Desmos, so I'm going to show that quickly. Just going to run that up to 100 samples. Now I've got my 100 samples. Sweet. Sounds good. In the CPM tool, it's going to be kind of annoying, so I'm going to have to hit this a few different times, 5, 10, 15, 20, 25, and so on and so forth. In the TI, not so bad. Let's see if it's still open here. It is. I just need to go up here and change this number to be 100, and then store it to my list and call it good from there. I kind of like the Desmos thing. It's just quick and easy and fast, and I've got it. I can randomize it like pretty quickly. So you just do this. You do it, and you go through and count all these numbers. Like, okay, this one is a no. This one is a no. This one's a no. 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 Yes. 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 And so on and so forth. Again, I am going to do this in Excel because it'll just get this video to be shorter here. So here's my first trial. I've got my 100 samples. And I found that 58 of them were below and that 43 of them were above. And if you look across these five samples here, well, it's just a little bit harder to get those crazy numbers. Like this one is more off. It's like off by 7. But like think before our margin for error was like 14%. Well, this is like 7, and this is the crazy one. This is the super high one. And this is off by 7 here too, I guess. But this is only off by 2 and 2 and 2. Like just we're getting much tighter numbers here, and we're seeing that play out in the percentages there. So let's jump back to this question here. It says record the results for 5 trials. Okay, check. We have done that. Now we're going to do that with our class data. Again, I'm going to kind of mock this up and just say, okay, so here's person 1, here's person 2, here's person 3, 4, 5. And then I'm just going to take all these numbers. And I know this isn't exactly right, but again, I just didn't want to do this a bajillion times and do all that. So here was my, oh yeah, here were my means. So my means much, much tighter, right? Like I'm at 1%, 2%, 1%, 1%. And then, of course, the mean total is still that same 60. So now here, if I take that data and I throw it out here and I've ordered it. So I'm going to take off the bottom 5%. So I'm skipping these two numbers. And then I got to find the mean between these two. Well, that's obviously just 55. And I'm going to do the same thing here. Again, I've got these kind of crazy values of like 68, but I get to throw that out now. So I'm going to find the mean between these two, which would be, or not the mean, but the median, which I guess in this case would still be the mean. So I'm at 64 and a half. So now my lower bound is going to be at 55. My upper bound is going to be at 64. So jumping back into this, my lower bound was at, I already forgot the numbers again. I'm great at this. Okay. 55 and 64. I'm going to write this down while you're not looking at it to see. So I'm going to find that difference again, 65 and 54. That'd be 9.15. And I'm going to divide it by 2 because that's going to tell me my plus or minus, my margin for error. So I'd end up with 4.75. Well, think about that. Before we had 14%, now we have 4.75. We have a third, less than a third, or not quite a third less margin for error here. And I kind of missed a key part of this. I realized when I read this here. They agreed that they should have a larger sample size of 100. I skipped this part right here, where it says, assume the student council finds the same 60% support there. Um, so jumping forward here, so now our total, our mean was still 60, but now I'm at plus or minus 4.75 per percent. So what that means here is that I've got my average, my true average is going to be somewhere between 55 and 55.25% and 64 point, let's try this again, 64.75%. So now do we think that the principal will be convinced? Absolutely, he should, because even at its worst possible outcome, which is still likely, I'm well above 50%. So yes, the principal should absolutely be convinced with this larger sample. So here is the whole takeaway here that might feel a little bit like no duh. If you take a smaller sample, you're going to have a higher, let's not put an arrow there because I've got an arrow next to it, higher degree of change. If you've got a larger sample, you're going to have a lower change, which isn't that crazy. But the thing that I think that's cool about this is that instead of saying, well, I think it's this, it should be around there. Instead of saying it should be around there, I'm getting hard evidence. I'm saying, no, we feel very confident that it's going to be plus or minus 5% there. I'm not just trying to ballpark something based off my feeling. I've actually got a mathematical procedure to say, hey, I feel like just based on the math, it's going to be, and I'm just going to drop off the decimals, it's going to be between these two numbers. That's the true average, somewhere between there. And I've got this mathematical process of saying it should be around 60%, but I'm not quite sure, plus or minus something. No, like this is actually a mathematical like process to get there. So that's kind of your big takeaway. All right, team. Jump into that review and preview. Let me know if you have any questions. Would love to hear from you.